Restrictions, Part 2. In Part 2, what we did is we found the domain of the square root of x squared plus 7x plus 10. And the way we did that is by factoring what was inside the square root, and then sketching it quickly to find where is this second degree equation, where is this parabola positive, where is it above the x-axis. Now, an alternative to doing that is this other method that I'm going to show you. And the way it works is you're going to tabulate all of the information. And the first thing we do is we write down this x squared plus 7x plus 10 factored. So it gives you x plus 5 times x plus 2. And then we ask, okay, when is this greater than 0? This is greater than 0. So first of all, we look at each factor independently. So we're going to start with this factor over here, and then later on we're going to move on to the second factor over here. So the first factor is x plus 5, and we ask when is this greater than or equal to 0, and that happens when x is greater than or equal to negative 5. And the second factor is x plus 2. When is that greater than or equal to 0? Well, that happens when x is greater than or equal to negative 2. So we have these two bits of information, and what we're going to do is start building a table. So we're going to have our number line over here. So this is going to be the x number line, kind of like the x-axis. And on the left-hand side of this line, I'm going to just write down all of the factors in this column. So the factors of x squared plus 7x plus 10, we said were x plus 5 and x plus 2. Now, I'm going to call all of this under the square root, I'm going to call that polynomial p. So this is really just a polynomial with respect to p of x, polynomial of x. So that when I multiply x plus 5 times x plus 2, as if I'm multiplying the elements in this column, so the top times the bottom gives me polynomial x of x, p of x. Now, on our number line, we're going to mark off negative 5 and negative 2. So what we're doing is in increasing order from negative infinity to positive infinity, we're marking off these important points that we've found. And we're going to draw these lines over here, and that's going to help us create this table. And the first thing we ask ourselves is, okay, at x equals negative 5, what is the value of the polynomial? What's the value of x plus 5, this first factor? Well, at negative 5, we have a 0 here. X is negative 5, so we have negative 5 plus 5, 0. And at negative 2, we have the second factor, x plus 2 is 0. So it's a 0 here. So we've put in our zeros, and now we come back and we say, okay, fine. For our first factor, x plus 5, what is the sign, plus or minus, for x if x is between negative infinity, and negative 5? Well, we know that x is greater than 0. X plus 5 is greater than 0, which means it's positive only if x is greater than or equal to negative 5. But if I'm taking numbers smaller here, then this should be negative. So here's positive and here's positive. And now we're going down to the second factor, and we do the same thing. For values greater than negative 2, it will be positive. X plus 2 is greater than 0 only when x is greater than or equal to negative 2. So this is positive over here, but everywhere else it's negative. Now, our polynomial p of x happens to be x plus 5 times x plus 2. So the sign that we're going to observe in these boxes here is going to be the product of the signs in the boxes above. Now, at negative 5, we get a 0. The polynomial goes to 0. And at negative 2, we also go to 0. Now, to fill in the boxes, we do negative times negative, that's positive. So we observe that the polynomial p of x, which is x squared plus 7x plus 10, is positive for values between negative infinity and negative 5. It's negative between negative 5 and negative 2 because we have plus times minus, that gives us negative. And it's positive for values between negative 2 and positive infinity because positive times positive will give you another positive number. So we're only interested in values of x that are positive. So here and here, which means from negative infinity to negative 5 we're interested, and from negative 2 all the way to positive infinity we're interested again, including negative 5 and including negative 2.